recording. I imagine it's 4 of us. So welcome to the Cloud Robotics Working Group meeting. Nothing on the agenda for today, really. I hadn't even planned on looking at Cloud Robotics hub sources or anything. So anything goes. Any news you've got? Anything you want to chat about? The floor is open.
Yeah, I'll start by apologizing for missing 2 weeks ago. I was all excited to be there and forgot that UTC and Pacific Standard Time are different alignment than Pacific Daylight Time. So I showed up an hour late and then realized I missed it.
Oh, that's
so
painful.
I started watching the YouTube, and I appreciate having the recording. I haven't made it far enough to engage in a deep discussion on the topic, but it so far looks very promising, though a little bit of everything, the Zenoh stuff. It can do it any sort of transport way, which is good and bad, I feel like. And maybe he got into that you discussed, but yeah. So first, sorry I missed it. Second, thanks for making a recording.
No problem. I'm glad someone's using it. On a side note, that does actually remind me of... Oops, I shouldn't be doing that. Reminds me of something that came up from Eric's talk, which is that someone posted a comment on the talk video. And of course, I'm the only one with the YouTube login. So it does make me wonder if this happens again. What should we do? I don't want to talk on behalf of the group all the time. I'm wondering if sharing the details out or just posting somewhere saying, oh, we've got a comment, let's all reply to it.
Is it? But these comments are public, right?
They are. Yeah, so I could just say, there's a comment, take a look, and we can reply with our own accounts. That would make sense.
I think everybody should just reply, and you shouldn't feel shy. I mean, I think it's more important that somebody is responding. So if you feel compelled to respond, I think you should just go and respond. I think that's good. And then if you remember to tell us, yes, I might look at it too. But what was the comment about?
It was a while back that it happened now. Let me find it quickly. Comments.
And while you're doing that, I think, Mike, a question you kind of didn't ask directly is, should you comment as the Cloud Robotics Working Group or as your own individual user? And I think it's probably easier for you just to comment as yourself, and then the account just won't comment.
I could see that. I responded from the account, but said Michael from the group here.
Yeah, I'm just thinking, if you're worried about, hey, responding all the time officially, then we could just make a policy that the account just doesn't respond and individuals do, and then it's up to us to respond, and not anyone like, oh, this needs a response.
Yeah, that could work. That makes some sense. So let's go with that. Now, and I've posted the link and then immediately lost where I got it from. So the comment said, is there an option to run Gazebo and Arviz on the cloud? If not, how do you work around this? So yeah, I gave my best response, and yeah, if anyone wants to pile in and add more, and then in future, like you say, I can respond from another account and alert you that there is something if you haven't seen it already, and you can respond. Of course, once we take off and we have several 100 million subscribers, might not scale as a system.
Let's make that decision when we cross the 100,000.
Burn that bridge when we come to it.
Yeah.
This comment and your response lend themselves very well to an FAQ on our Cloud Robotics Hub. What do you think of that?
Ooh.
I think it's a good question. I think I'm actually glad they asked that.
Yeah, that's a good idea. Add that to the to-do list.
Yeah, part of me reads that question is what most general public, robotics public, wants to see out of this working group is where's the one line I have to run that gets me Gazebo and RViz in the cloud where I don't need my NVIDIA or messing with all that stuff.
Yeah.
Is that going to be as easy as they want? No, but
there are images. We do use a Docker container that is GPU accelerated, and as long as you have a VM with the GPU, you just deploy the container. So it should be simple enough.
That sounds like something worth sharing on our site as well.
We can definitely do that. I mean, we did publish about this, so there's references, and there's also the repository where we build the container image. It's not up to date with the latest coolest way of building containers. We're still just doing a regular Docker build, but it works. And instead, since we were mentioning Zenoh at the beginning, we had been using Zenoh for a while, and now that they released the 1.0.0 version, actually it did solve the only issues we had left with Zenoh, which were, I don't remember if it was something with actions, or I would need to ask my colleagues who were working with the big robot and with the multi-robot setup. But basically, before with DDS over VPN, we really had trouble because we were hogging the VPN and hogging the network. Some topics, even though they were not subscribed, they were going through the VPN. I don't know why. And they were, and instead with Zenoh, it's just you whitelist the topics. You can specify a maximum rate for publication. And basically, it's so much easier to configure the network, the Wi-Fi with multiple robots on the same Wi-Fi, and we're just going to use that for our work now.
Nice.
Amazing! I didn't realize you were actively using it, so you would recommend it as well?
Yeah. I mean, compared to what we tried up until now, which was a combination of a million things, ROS Bridge and the ROS Duct that was putting it together. Then we went with OpenVPN. Then we went with WireGuard plus Cyclone DDS. Then we went with Zenoh. They all of them had some issues. And right now, our multi-robot demo with a bunch of sensors, point clouds, and everything is working. My colleagues are telling me. I haven't tried it myself, but they managed to have a setup that where everything is coming through, and they can actually control the multiple robots on using multiple foxgloves and one for emission foxgloves that sees. Basically all the topics and all the robots. So all of that is, before it wasn't working simply because of Wi-Fi, DDS over Wi-Fi not doing its thing.
That's cool.
That's pretty
I
cool.
intended
How many
to...
robots do you have in that multi-robot setup?
Now I think my colleague Leo was just working with 2, but what I intend to use it with is in class. So in class is going to be 6 robots. But I haven't tried it yet, so I haven't tried that setup with 6. The problem seemed to be, as far as I understood, that we're talking about a mobile manipulator which has 2 lidars, 2 cameras, and for using MoveIt, it wants the point clouds to build the octomaps for collision avoidance when planning the arm motion. And so when you turn on MoveIt, you can decide whether you really want or not to receive the point clouds for doing the Octomaps, and it seemed that these point clouds were being streamed, although we didn't want to receive them. So there was something, I didn't investigate exactly what was the problem, but some topics that were not subscribed were still coming through the VPN. We would see a lot of traffic, and we didn't investigate further. But now we don't see it with Zenoh, so we're happy, and I don't want to waste any more time with networking. Because it really took a lot of time already.
This is where Eric would tell you that multiple ways of transmitting over the network is more reliable. So you're going to have to triple your network setup.
Exactly. As a matter of fact, I also tried Eric's setup, but just with the containers that they ship with the code. And it worked. I have not yet had the time to. I wanted to actually try to do the. They distribute containers, so a nice pattern that we can use since we're doing cloud robotics is to use their containers as sidecars. So just attach them. I lost my connection. I don't know if you can still hear me. So we could just use them as sidecars. So just attach them in the same pod as the other containers that we're running, and we would get basically their networking from the. But I haven't tried that scenario. That's how we did it with WireGuard, by the way. So our ROS container is unmodified, and we just deploy the ROS container in the same pod as a WireGuard container, which basically gives us a VPN additional interface in the pod, and on that we can stream DDS data.
Why do you need to
so I want.
Yeah, I missed that part. What? So the point cloud being converted into Octomaps and consumed by MoveIt, that's all on the robot itself, I'm assuming, right?
No. We're actually running MoveIt. We're just running the controller on the robot. We're not running MoveIt on the. We're doing the planning of the robot.
So it's like an edge computing kind of demonstration.
Yeah, exactly. I mean, we have our local cloud, which actually is a near edge, if you want. It's just we have it there, so we just do all the planning there. And there was a thing, if you go and read Eric's paper, there is one thing that they say, which is that they don't recommend using their solution for very large topics. And indeed, the point clouds are exactly that the kind of issue that we have.
Cool. I wonder if we should do a follow-up blogs on, and then we tried it and it was good. Because I like hearing that. And I plan to do some testing myself and just haven't got to it. So yeah.
Yeah, that's what I posted an issue already on the Cloud Robotics Hub as a sort of, we should have a recap blog post of all the ways of doing connectivity, and if we can extend it with our experience and what worked and what didn't work, then I think it would be valuable to the community.
That is a great point. I have not checked the issues board. I'll pop it up quickly and see if there's anything interesting going on. There's one issue, and I think it's, blog post proposal, wrap up connectivity approaches. Still, the system works. If we check it. Maybe I should sign up for emails or something.
Yeah.
I just realized that I didn't yet watch it. You can watch a repository and you will get all of those, every ticket and every PR, unless you unsubscribe. It's very convenient. I recommend doing that.
Mm-hmm.
So you just click watch on top.
All activity, nice.
The next thing that we're planning to do is also something that Eric was mentioning, which is using more even more AI to do robotics. So the vision language models, the LLMs, and all these things. And now, I mean, with the open, there's so many open source models that are working. Even, I mean, yes, you still need a GPU, but we have a cluster with the GPU, as I was mentioning, at the university. And so I'm having quite a lot of fun now deploying the models, and I want to use them now with the robots. And that's also a cloud robotics thing. Although I am already seeing that people are pushing them, making them so small that they imagine using them directly on the robots. I don't know how likely that's going to be, especially for the vision models. But yeah, that's also another interesting trend that Eric was mentioning, and indeed is happening.
I don't know what the cutoff of large language model is. I feel like a good cutoff is can't fit on a robot.
What kind of
Yeah, but
GPU
even
Giovanni? Is it still?
we have an A30, so some A30s actually.
Okay.
Yeah,
So the models don't. I mean, you can run there's the 1 billion parameters models that are tiny. You can run them. You can even run them on your laptops if you want. The A30 has 24 gigs of GPU RAM, so you can run the some models even. I mean, the 14 billions or the I think I was even able to run the last Quen 32 billions model was fitting actually in the on the GPU, but then was too slow, and I went back to the smaller 7 billion parameter model. But they work quite well and they're quite powerful.
Interesting.
I imagine that an LLM or VLM related question in the FAQ would be a good thing to add as well. It's what everyone's talking about right now.
There's really a lot of papers, a lot of research going on basically, apart from humanoids, everything else they talk about is this the generative AI applied to robotics.
Yeah, I mean, it helps the industry when somebody raises $400 million just on the promise of building a foundational model for robotics, right? It's sort of the a smaller scale open AI moment for robotics, I guess.
Which company was this?
Oh, this is physical intelligence.
Absolutely. Lots of money, lots of companies.
Klaus, no, what's his name? Hausmann. And then, yeah, anyways, it's, yeah, they are very secretive in terms of what they do. They don't seem to have, I mean, they showed some demos, but it's not clear what their first product is going to be. And what I've gathered through the grapevine is that they might just be pitching, what they're pitching the investors might just be sort of an open AI story where it's not, hey, we're going to build a robot to do X, or even we're going to solve this and that problem. It's more like we will be the go-to place for foundational models for robotics. So give us all the money, which worked for OpenAI. I mean, yeah, they were a company and a research outfit first before they became, before they had a product. And that's what I'm gathering, but I'm not sure whether that's true.
Sounds like someone to keep an eye on at least.
I think this one will be more like you won't be able to pluck your ears hard enough to not hear about it, because if you're raising 400 million, I think that people will talk about you whether you want it or not, and they also want to be talked about. I suppose that we will be getting a little bit like with the Boston Atlas, right? Like, tell me somebody in the robotics industry who hasn't seen a video of the Atlas. I suspect it's going to be similar to that. But it's exciting. Don't get me wrong. I'm totally bullish on that. But yeah, I think we're all the boats are lifted a little bit by that.
Yeah, we somehow, since we had contact with Eric from Ken Goldberg's group, he was also, they were also commenting, Ken was also commenting about the fact that the demos that are coming out of Boston Dynamics are more about robotics engineering. He calls it good old-fashioned engineering, and then you have this physical AI companies doing end-to-end learning for this longer horizon tasks. Like the demo that they have is this robot picking out laundry from a washing machine and folding it on a table with multiple t-shirts and pants and everything. It's quite impressive, the demo, to be honest. But there's always this I'm a self-taught roboticist, so I imagine that there's been quite a lot of debate now on whether to do programmable primitives, so primitives that are engineered and pre-programmed, versus end-to-end learning of things. And I imagine somehow I feel a bit more older style, and I like more the things that you can compose, that you can program, and you know what they do, rather than imitation learning. But maybe I'm just old. That's just it.
No, I'm with you. I think actually one of the biggest issues with neural networks is that they are opaque, and even worse, if you want to change them, you have to retrain them. So I don't know whether I shared this anecdote here, but when we were doing RoboCup back in 2001, we were it was the night before the finale in the Simulation League, and we were at the on site. This was the German Open in at the time it was in Paderborn. Later they moved to Hanover, and the two finalists was one software engineer. He wasn't even an AI student, from the University of Amsterdam. He went with a classical approach, and he was playing against I think it was the team from Dortmund, and they were back then already used a neural network approach. And we went in there and we talked to both. On the one side, there was this one guy, just updating his rules. He was totally relaxed. On the other side, there was a team of 5 huddled around that monitor, pulling their hair out, and they couldn't understand what was going on. We asked them, "So, what's wrong?" They said, "Well, every time he attacks in this angle from this side, he scores a goal, and we don't know how to teach our network to stop him. We've thrown like a million examples at it, and it's just not getting it." Like, the other guy didn't have any such problem. He analyzed the game, was like, "Oh yeah, they usually do this, so I'm gonna update the threshold for my goalie when to run out and when to stay back a little, and yeah, I'm good." That is, in a nutshell, the problem with LLM, with neural networks. And you see that too, right? Just if you look at the vision ones, right, the image generators, they may have updated recently, but as even a year ago, if you ask them to draw a sign with some writing on it, it would 100% get the writing wrong, right? It couldn't do any writing. Why, right? Like, what's so hard? We have LLMs that can write like Shakespeare and valid C++ code. Why can the the image generators, not even spell America correctly, or whatever you wanted to write on that thing? Well, the reason is because it wasn't trained on that, and it was, and the input and output is, it's pixels and pixels or whatever. And this is a real big problem. And I think this is also what describes the wall that they're hitting right now in AI training, right? Where it's all just zero shot. Like, you ask a question, it doesn't do much reasoning. It just basically has the answer in all of its parameters. The Strawberry, the O1 model, is different, right? It does a lot of inference time reasoning. And I think that's really exciting, but I think we need to do a lot more along those lines. So I'm actually totally with you, Giovanni, maybe because I'm the same generation as you. But I think we need smaller models that can be composed, that are inspectable, where you can change one and not have to retrain all of the rest. And so, and I think especially in robotics, right? So the issue that I see with robotics is that, unlike language, robotics has a lot of domain knowledge, and it's called physics, right? Like, the laws of physics are very well defined. The laws of language are not. Like, if you look at the history of NLP and speech recognition and so forth, people in the past used rules for language, and they said, sentence structure is like that. And then there was this guy Jelinek, and he was a big guy in speech recognition, and he made the joke that every time he fired a linguist from his team, his accuracy went up by a little bit, right, on his words. And that's because he was pushing the statistical approach, and for good reason, right? Because language, we don't speak very precisely, we don't always follow the structure and so forth. But physics is not like that. Physics is very precise, and we know the rules. So you'd be a fool, in my mind, if you try to relearn physics from observation. It's like, why? Okay. I've spoken for a long time, but I'm with you, Giovanni.
Yeah, but okay, then, because I was bringing up now, in fact, what you brought up at the end of what you were saying, learning physics from examples. But this is also one of the other big topics that is going on. There's this famous paper about world models by Schmid-Huber in 2018, where they learn the model of the environment where the robot is in, so that they are able. You see, there's also lots of papers coming out now. The completely AI generated Doom. So they basically learn the model of the environment by training a neural network, and then somehow use this to predict the future or predict the effect of an action, if you want, which is actually the thing that you want to have for a robot. Because then, in theory, you might not need to understand physics, but you might want to have something that says, okay, if I try to pick that book from the middle of the shelf, all the other books that are next to it are going to be pulled with it, and they're going to fall down. I'm not really here. I am not really sure that it's so easy to just put in the physical rules, because we are somehow missing the semantics. The robot is still missing the semantics to apply the physical. Yes, the physical rules are easy. I mean, there's gravity, basically. That's what the robot should care about. But then the interactions of objects with each other, that's a bit tougher, I guess. And even understanding what objects are for instance, which is the semantical part. So that somehow this other thing with the word models, I still find it, if you want, as a way that you could use to keep the LLMs in check, or now the fashion is you use a VLM, you attach it to the camera of the robot, and you say to the robot, go explore the house and fetch me this thing. This is what most people are doing this nowadays. But still, some of the actions that the robot will do without a prediction of the physical effects of the actions are really dangerous. I mean, they can drop things, they can hit things, they can make things fall after another. And maybe these word models, although it's relearning the physics, maybe that's one way to keep those things in check, because you can somehow use model predictive control to avoid shitty situations somehow.
A few years back, I attended a talk from someone who was working at the Uber self-driving, and she said at the time, there's basically two approaches. One is you throw a giant neural network at it, and the other is what we've been talking about. And you tend to find quick results from the giant neural network that are surprisingly impressive, which get startups lots of funding, such as self-driving startups. And then they fall off a cliff, and the other approach starts to come through. So I don't think it's an old thing. I think a lot of Gen AI is rehashing what we've already seen with AI. And I also am in agreement that the giant neural network model is not the best one in most situations.
Giovanni, did you look at all into these physics-informed neural networks?
No. I don't know anything about this.
Have you heard of them before?
No. What are they called?
Physics-informed neural networks.
No, never heard.
I'll send you a link. It's I'm trying to make heads and tails of it. On the surface, it sounds absolutely perfectly correct to me, in the sense of like addressing the issue that I just stated. But in practice, I don't know how well that sort of marriage between physical rules and neural networks actually is applied. My super high level understanding is that it's basically training a neural network, but then every training example is checked against some rules of physics that basically constrains the parameter space, so that you will not learn so that you will only learn within a range of weights where it's still feasible somehow. And please don't quote me on it because this is not doing it justice. But yeah, I was wondering whether you knew more about it. It seems very relevant to robotics.
Never heard of them, but thank you for the link. I will definitely look at them. No, I know nothing about these things, but I'm writing a proposal right now. This could be very helpful, actually. Somehow, the another of the thing that you see doing, since you were mentioning, and I agree, this large model. First of all, the very large model are basically impossible to retrain for normal people, even for universities, because the amount of GPU time that you need is just beyond reach. But then, luckily, I mean, you have this other thing that is very much in fashion now, which is retrieval augmented generation, which is somehow, if you want, the cheap way of saying, hey, don't use what you've already learned, but this is the context that you should take your answer from. And somehow that is instead a lot easier to use for constraining the type of replies. As a matter of fact, lots of I'm looking at those things not just for robotics. Of course, for robotics, they start to write papers also about these things. They call it embodied retrieval augmented generation. So you basically learn from the experience of the robot, and you store it in a way in which then an LLM can actually make use of what you have stored and re-give it back to you. But then also for instance, at my university, they're looking at retrieval augmented generation for generating agents for helping students answer questions in a course. So you really upload all the course materials to one of these things, and then the students get for free an agent that is able to tell you, you didn't explain why that table works that way on that slide. I can tell you why. And those are, if you want, the poor man's alternative to retraining a neural network, a very large neural network, but constraining the answers. Of course, there's other problems with them, but that's also something that we're looking into now, and even for robotics.
You've got a lot of reading up to do.
It's impossible to stay up. That's how I feel like. I mean, if you have a job and you can't just do 100% research, and even if you can, I think you can't keep up.
It's impossible to keep up even if you do this just this, and I don't do just this. So yeah. So there's really an incredible acceleration of what is going on.
Sounds like something AI could help with.
Yeah, exactly.
And I didn't have time, Chris, to look at last time we spoke, you were mentioning you have this fleet management solution that you are implementing. Didn't have yet time to look at it. It's I'm writing a couple of proposals now, so it's a bit tight. Are you still working on it? Are you moving forward? I checked it. I just saw that there was no README, so I stopped there for the moment. But I wanted to come back.
Yeah, we did actually update it. I was actually going to show it here real brief. it's not quite ready for an announcement, but I can share just a little bit like what it looks like right now. I don't know whether Phil and Michael, you remember the context, but I mentioned to Giovanni that we're implementing this open source fleet management dashboard, and of course it is meant as it's meant to serve two functions. One is as a reference implementation of how you would use transitive capabilities, but then also, like, surprisingly, many of our users don't actually have any web dashboards for their robots yet, oftentimes because they're just at that stage where they have, maybe 5 robots and they've gotten along with, Arvis over VPN for now. And so this is also, a starting point for them. So this is what it looks like right now, right? And again, all of this is open source, and a lot of the functionality is provided by transitive capabilities. But yeah, you see your robots, you see whether they're online, you see whether they're charging or not. We have a little feature where it actually gets the location from a geo IP lookup, so you can tell my test robot is here in Menlo Park. You see which capabilities are running on it, and then when you click on it, we currently have just like a little demo map just to show, for this is obviously an outdoor map. We're also working on an indoor map. This is just a plugin, like a stand-in for now, a placeholder. We would, obviously on a normal robot, we would use the actual video camera stream. You have like health monitoring here at the bottom. And then you can also go to the specific ones, to the specific capabilities, and just pull them up here, and you would get, well, in this case, the same thing. But I guess the more important point about this is that it's open source, Apache 2, so you can just fork it and use it. And very much work in progress. We haven't announced it anywhere yet. But we plan to polish this a little bit more and make some announcements.
That's really cool. Thank you, Chris. Thank you for the demo also.
Look forward to seeing your guest talk.
Yeah, I can give a short talk about this at one point. I guess at that point, we would want to look a little bit even at the code to show how to use it, or what? Did you have anything specific in mind, Mike? You would want to learn about it, or no?
I personally love looking at code. For a recorded demo, I'm not sure. I guess if there's a high level flow that you can demonstrate, but probably it would be more about how can you take this and extend it for yourself, maybe that amount of code.
Yeah, I think that's a good idea.
I would also put in something simpler. I mean, this is essentially a chance to advertise. Someone's going to come across this and they want to know how to use it. Like,
yeah,
the quick, okay, this is available now. How do I put it on my thing?
Yep. I think that's a good suggestion. So we could go through fork the repo, run npm install, run npm start, take a look at a robot. That's a good idea. Yeah, happy to do that once it's soon. I don't want to say once it's ready, because that sounds like this never kind of thing. But yeah. So thanks for the invitation to do so.
So software engineers reply to a product manager there. When will it be ready? Soon.
I remember two things. First of all, one question: you're also using MQTT there for connecting to the robots, right? Because I remember
that's really the essence of transitive. It's this MQTT sync protocol that we invented. It's a data synchronization on top of MQTT, and I always like to make clear the distinction between the two. MQTT is just PubSub. It doesn't actually synchronize data, it just sends messages. Synchronizing data is a different animal, right? Because when you synchronize data, think of it like Dropbox. It's stateful. You need to know what data do you already have, what's the update, what's the modifier, and you only want to send modifications, not just the whole data every
not
time.
just the flow, exactly.
And but you do have to I mean, it gets into ASIC, right? Like from databases, like eventually, and the most important one being eventually consistent. That's a little bit of the challenge, but this is super relevant in robotics, right? So just take the example of let's say the robot pose, right? Your robot moves around, it loses network here and there, it comes back online, but on the dashboard you want to see the robot, right? What do you do when it goes offline? You still want to show where it was previously. You want to show that it's now offline and the data may be outdated. And then when it comes back online, you want to show the latest. And yeah, anyways, but yeah, it's built on MQTT.
Yeah, because I remember you were also asking our speaker the last time about Zenoh if they have authentication and authorization, because they didn't have authorization, right? Because you use
they do have authorization. Yeah, it was a very detailed question. Like in MQTT, in most people use Mosquito as the MQTT broker, and there they have a plugin system for authorization and authentication. And we use that very heavily because we need to limit the access to specific topics in a very detailed way. And that's what I was asking him about, whether Zenoh allowed you to write plugins like that. And unfortunately, right now, the answer is no. But he seemed very interested in that, so we'll probably have a follow-up.
Yeah, also because it does make sense as a security as you use it. I mean, that topic comes from the robot. Only the robot can publish on it, and that's it. That makes a lot of sense. Yeah. You don't want you don't want anybody else to be able to publish on the topic. And I remember another comment that you made a while ago about the fact that most people that are working with robots don't like JavaScript. And I have to confess to that that I am guilty of that. Instead, you are clearly very comfortable with all these web technologies. I was comfortable with web technologies, but before JavaScript became the main web technology, I have to admit.
Yeah. Yeah, it's a sort of a divide, right? Like we do, obviously, on the robot, you need C++ and Python and Rust and stuff like that. But then for all of that remote management and monitoring, clearly the web is the sort of the stack to go with, because of the distribution, the availability on any device. The APIs are fantastic. And so, yeah, people like us at Transitive, and then also the Foxglove people, right? We're sort of the crew that works on bridging that gap, right? By making web tools and then connecting them to robots, making it hopefully easy to use. But yeah, if you want to extend it, there's always some learning involved.
Yeah.
Have you heard of the AWS shadows, IoT shadows? It sounds similar, the synced state stuff. Is it the same?
Yeah, it's very similar. And I think Greengrass even uses MQTT as well, doesn't it?
Yes, it does.
Yeah, and the Google IoT Core, when they still had it, I don't know whether it's still around, was also based on MQTT. I think Microsoft Azure has a IoT, and it's all MQTT based. And then that idea that you have sort of the should be and as is state is pretty popular. One thing about I was consulting a customer who was using Shadows and Greengrass, and from what I remember, maybe they've changed it, but there was sort of a limit on how often you can send updates, and it was something. Was it once per second or was it once per minute or something like that?
I feel like I've sent updates more frequently than once per second.
Okay, maybe they've changed that. Or maybe
I definitely have. I have a sample online that does it, I think, 10 or 20 times per second.
Oh, cool. Yeah, maybe they've increased that.
Interesting.
Yeah, it's a good. I think it's a good model. This is very similar. The MQTT sync that I described is very similar in that regard.
I think one of the things that I've always thought it'd be useful for, and I'm sure you've thought of this already, but for the others as well, is having configuration for robots. So you can have one source of truth image firmware for your robots, and then the configuration per robot is just stored in your synced document.
Yeah, we do have that we do have a capability. We call it configuration management. But yeah, the implementation of that is not actually. I'll show you. We follow this model here, which you may have seen before, which is very popular, where you have like this hierarchical approach, right? You have fleet defaults, and then robots can override some specifics. And just like in CSS, the most specific is applied. So when you follow this path, you see that the speed is taken from the fleet, but then the name is taken from the robot specific, and you can override different things. I think it's a very good model. And then yes, this meshes very well with that MQTT sync idea or the shadows. This is pretty early. Like we built that for a customer who really needed it. We're not doing too much on this right now.
Are you logging the config along with the robot when it comes back? Let me give you some. What I'm thinking here is, you have a different config on each robot, and if something goes wrong, you have to be able to duplicate that.
That was exactly that is. Yes, that is something that first customer that we had asked us to do, because exactly for the reason that we said, they need to be able to, when they do debugging, right? Like they may know, okay, well, yesterday at 8 a.m., this robot did this and that. I need to really know what was it running, which version of software, what configuration, what speed limits, what thresholds, what footprint, shape, whatever. And no, we don't have that yet. But it's on the roadmap. We don't, like I said, we don't currently actively work on it, but if we were, this would come very soon.
Yeah, so it seems like something to tie in with any sort of other data about it, just what the actual config it's running. But yeah. I'm not doing it for you right now, so I understand how it takes time. There's other priorities.
Yep.
Yeah.
No, we've lost Giovanni. Yeah, speaking of which, I always like to remind people you are more than welcome to implement capabilities for Transitive. It's open source. You can, and the distribution is the table is set there. You just we will help you with distribution, right? Like you can add it to our to our list of capabilities. Our users will see it. We will co-market it. So if there's something that you're really passionate about and you want to build, and you're starting out, you haven't built much, something to consider, right? Because it will give you a good set of starting material, right? You don't need to, for instance, take care of all of that updating and namespacing of data and cross-device management and obviously the data sync and so forth. So yeah, if there's anything that you have in mind, let me know or just try it out.
Yeah, sounds good.
Maybe a crash course in JavaScript if it's been a while. I assume it's in JavaScript.
Yes, that is all in JavaScript, because on the front end you clearly need it, and then it's nice to be able to. The real beauty of Node.js when it came out was that you could write the exact same code on the back end and the front end. You can even share files, right? And that makes it so easy, especially if you have to deal with serialization, deserialization. You just have one class which has a serializer, deserializer. You are literally using the same class on both ends. And yeah, it's quite beautiful. Sometimes you make a mistake, right? You start implementing something on the front end, then after a while you realize, oh no, this actually needs to live on the back end. Well, you just copy it from one editor window to the other, problem solved. In the past, you had to then re-implement it in the language of your choice on the back end, and that's no longer the case. So yeah, it simplifies a lot of things.
Yeah, I can definitely see that.
Best explanation I got until now why Node.js is so successful now. Mike, the next speaker is already the next time, Tomoya, or is it later on?
So we have Tomoya on the 16th. So that's not next session, but the one after. I've also asked Matthew Hansen if he'd be free to talk. He said he'd be free November, December time, maybe. So I sent him a message. We'll see if he's able to talk next session, but no confirmation yet. So fingers crossed on that one.
Okay.
And then if there's any other ideas you've got, we could try looking for specific subjects as well. Like maybe we could try and get someone from a startup to talk, or I don't know. That's as far as I got with that thought. But try and make sure we keep our talks varied and interesting.
So something coming back to, if we have nothing next session, nothing planned, it could be fun. We talked about trying to implement one of these things, that the fog ROS or the Zenoh stuff. We could do a live session, us all struggling to implement one of these setups. I don't know.
I like the idea.
That could be fun.
You know, that there's so much of handing something that you know really well off to someone who's just joined your team to find all the problems with your documentation, you know, stuff like that. How much time does it take us to read through and figure out what he said, what that means, and why my setup isn't working? I don't know.
Something I've done. Oh, sorry, go on.
No problem. I did do a pull request on his README because there was something unclear.
On Eric's README or on Zenoh's?
On Eric's README, yeah.
Something I've done.
Personally, I'd be more curious about Zenoh than FogROS. If there's sort of a simple task like a hello world that we could implement there together, I'd be totally up to that.
Yeah, that works quite easily out of the box. So yeah, that is definitely feasible with Zenoh.
Let's plan to do that then. That sounds like a good idea. Something I've done a couple of times for work, which has gone down well, is almost a stream of consciousness log of. I've even written stuff to myself where I've gotten annoyed with the documentation. I've been like, why does this not exist? This is terrible. But then you go back afterwards and you tidy it up into something that's actually useful and what was good and what can be improved. That tends to be very helpful for people that are familiar with their own code.
Going back to your I'm happy to do this next week, this Zenoh experiment live. Going back to the speakers instead, I think we have somehow concentrated on the connectivity aspect of cloud robotics only, or maybe because that's the hardest thing. For me, it was always the hardest thing, because I always had trouble having good connectivity for what I needed to do for the robots, which was mostly development and as a roboticist, so really using MoveIt and really using distributed ROS. But maybe there are other aspects that we should consider that are not just connectivity. I don't know if you have ideas there.
I can confidently tell you that it wasn't deliberate focusing on connectivity. So maybe that's an interesting trend that all of the talks have involved it to some capacity. But yeah, I like that idea. We can maybe simulation can try and ask for talk ideas that are more about using the robot once it's connected instead of focusing on the connection. That's worth keeping in mind.
Two thoughts, I guess. We could invite the OpenRMF folks to speak. That's more on fleet coordination, but it's clearly cloud. And then if you want to do simulation, there's a startup being very active right now. It's called Dallas, DALUS. I've seen them at two different places, a meetup just this past week, but then also at Robo Business they were pitching. They're still pretty early on, but they're doing something cool. I think, Giovanni, you will like it a lot. My understanding is that they are basically building high fidelity vision, like high fidelity from a rendering point of view simulation environments, just based on nerves, and sort of applying that to robotics to kind of help with the sim to real gap, I suppose. I suspect he'd be happy to talk here. It's somebody we could reach out to.
Great. I'm happy to connect, or if you've already got the connection, you could reach out.
Yeah, if people think that could be interesting, I'd be happy to find him.
Yeah, that's very interesting.
Please.
Okay.
I guess in terms of sessions, if I look at the calendar, we've got the 16th. Sorry, we've got December 2nd as our next session, which hopefully, well, either Matt will be talking at or we'll be doing a run through of Zenoh. 16th, which will be Tomoya speaking, and then the 30th, which I imagine we'll skip. Yeah, exactly. So I think if there are other speakers, we can look for the 13th of January or the 27th as potential dates. Yeah, let's the OpenRMF vote sounds like a good call as well. I'll look into that. We've got a couple of minutes left, so I think my normal summary is what's happening next session, but we've just said that, so I don't think there's anything to add. If you want to talk about anything else the last 2 minutes, that's fine. But we can jump off whenever.
No. Thank you guys then.
Yeah.
Talk to you in 2 weeks.
Yeah.
Bye.
Monday.
Thanks for coming, everyone. See you in 2 weeks.
Ciao.